any of the Python file is there, that is also you can import that test as a module. So when you do this, actually, if it has something print statement or anything, it will try to do those operation and complete. So now you will have in the test whatever there, right? You can actually access those method or function, whatever it is written. So in the test, I think mean function is written. So you can check mean is written and it will take number of list and return you the sum of the list upon the number, how many elements it has. So suppose you pass like range is one way to pass quickly the list. So it will calculate for you. So that is like any file is also acting as a module for you. That is also a Python's way to uh,
Any aliasing.
uh
For files, you won't give any aliasing. It's just like import
no,
and then
yeah, yeah, you can give either saying P or something. It is optional, but yeah, it will do the same operation or same way. So this is one thing, and that day we talked about systems and many other. Meaning system is a like inbuilt library where actually you can check all the things, system related things. Mainly, it is like getting the version of the computer related some stuff or uh, yeah, generally for we work on these paths and all. So I think it will talk to give you a list. Okay, it will give you path. Yeah, where actually I think these are the paths we added. Okay, so these are the paths which is accessible from here actually. Can see. Yeah, one is all are like these are Python paths. They are libraries where you are installing and all. And other is like site libraries where you are installing other Python libraries and where actually Python is installed. I think these are two parts. And we are currently we are working on one of the directory in which IPython extensions are got. So I'm not sure, yeah, why this they are printing. And so I think any other function which we can talk much. Path was there one more I want just check. So modules, yeah. Let's see. It is also going to give you a list of modules. Yeah. These are like built-in functions already present for us to use it. It is giving you all the functions or libraries which is accessible to us actually. So we are not much uh, yeah talking about these. But general is how you are going to import this library. So there is like importing file command is there, and other one is yeah importing as a file. And even if you aware like yeah which function you are going to use, you can directly use it. And I told one more thing was instead of mentioning this is names, you can write a star and
import.
import all the functions actually. Any questions on this?
Here, this is dot path that is the most used, I guess, right? Because
Yeah, first three are
we need to
mostly used, and we generally use like this for NumPy and Pandas. We meaning in this community, it is quite prevalent. Like everyone uses the similar, you can say syntax and all naming convention.
okay.
Yeah, and now I will like to move to NumPy. So before moving to NumPy, It is actually, you can say it's another. Okay, yeah, we wanted to talk about sorting also, right? Yeah, let's little much sorting. You might be knowing, like, yeah, nothing. It is
Arranging
what?
the order.
Yeah, arranging any number of list or anything. We let's talk how it is going to work with strings also. Yeah. So they already have this sorted one function. You can actually pass range. Suppose, yeah, let's make one numbers list. Nums equals to range. Uh, yeah, there is one random library is also there. So you can actually call that and then use random dot rand range. Okay, yeah, let's see how it is working. So just give how many you want, what is the start and 10. I think this should work. Yeah. So this is actually giving you, I think, random numbers between 5 to 10. Okay, only one value, so no point, right?
I mean, why they use random? It is like it is somewhat and
Yeah, let's skip that random as of now. We can actually give like range.
range could be better.
Yeah, range will be better. It will give you list of
List of
numbers. Oh, that is also not giving you list of number. Okay. So we can write for x in range. That is already there and list comprehension. Okay, here. Now you can see num says nothing but 5 to 6. Then on top of it, if you call sorted the nums, it will sort for you. Currently, it is already sorted, but you can pass this one more argument like reverse true or false. Then actually it will reverse for you.
okay. It is instead of descending and ascending specified, we are giving reverse equals to true, right?
Yeah, reverse is true, and if you want to give it false, it will give you ascending order. Yeah,
Oh,
that is the idea we have. And we wanted to check. Yeah, I just wanted to check how it will work. For suppose some string you are giving, will it work or not? Yeah, I think it will not work. Sample. So S is there. So S is a sorted capitalized. It's not. It will not have. Yeah. Suppose you pass the list. No, it is also doing the same for. You can observe in this. You can actually sort the. But actually, this is doing alphabetical, right? So yeah, it's what it does. It takes one of the all the alphabets as a one element and then did the alphabetical sorting, which is quite of understandable. Yeah, it should be expected behavior for you. So sorting is done. Similarly, play around with and try to. I just for us, yeah, class only. I'm just creating a dictionary because then it's as far I meaning, yeah, it will actually going to sort for you based on the key. No, so that is the idea. You can actually call these methods. Actually, it's already inbuilt, right? You don't have to think about it and how to use them. It's already there. Just meaning how to use them, you have to figure it out and where to use them. These are the challenges. It's there. And suppose, yeah, sums are random actually. You are giving Some has a string, some has a boolean, or some has. So just make a list of random things and try to play around and check how it is working. So suppose you pass a dictionary and you try to sort that. So how it is going to sort for you? That is the question. So is now in this case it is actually sorting based giving you only the keys actually, just not thinking about anything else. But suppose you replace this key with like false element, right? How it will sort? That is why you wanted to check. So false is acting as a zero. So that's why it's now sorted and send the false at the first place. And 1, 2, and 4 are like different. Now in this case, suppose you write like this, 4 is now not a number, this is a string. Then how it will behave? It is not going to sort for you because two comparison of strings and integer is not possible. So that is the idea. But if you put all them into a string, will it work? That also we can check. Yeah. So some comparison which is not allowed in Python, that is, yeah, these are like string or some for which we did not define at all. So it will not work actually. So in this case, as it is just now I converted all the numbers into string. Now it is able to sort it. And it's how it is sorting. I think string is also converted to uh, numbers for this piece, but false is also taken as this alphabetical order. So false is in the last.
Can we try reverse here? I mean, like
Yeah,
reverse
definitely. The
equals.
reverse will just do the reversing of the things. So it will give you same result in reverse orders. Yeah. So these are some dictionary and stuff. One major question is sometimes in come into picture is how you convert this key to value, value to key. So what you can do is you can write create a new dictionary saying that value as a key and key as a value. So what we can do is key and value. I hope we talked about this or not. B or k comma b in b dot items dictionary and their items and all how you can
Mhm.
access them, right? So this is actually it is going to generate the same key, same input which we gave, but here actually you can change it. You can say value to key and now it will convert for you. So d dash we can say it, yeah, d underscore. So now d is actually converted format where key is. These are like shorthands. You should be knowing about that. And in you,
Can
if
you
you,
explain this again? The D underscore, whatever the value you're giving. I'm not able to
oh,
understand.
okay.
I
So what
understood,
it
but
is doing is d dot
zero.
items. So suppose d dot items, it will give you all this actually key value things which is present here in the D.
Okay.
Forget about sorting. Yeah, we got T K meaning one is acting as a key and this is value.
Okay.
Dictionary we talked, right? D was,
Yes.
yeah. When you give this is going to give you this. But if with theory, it is going to give key error. And with 2, it will give you value. With false, it will give you false value. Right? 4 is already in the key. 4 will give you this. But uh, so if you print keys, it will give you all the keys. That is in keys are these things. And you can directly access values also. So values will give you these values
Right.
A, B. 6 and 7. But what we wanted, convert that dictionary where values will be acting as key and key will be acting as value. That was the idea. Question actually. So you can directly iterate over this k and v, where k will be keys, v will be values. When you pass this right items, so it will give you a list of key value pair. This is key, this is value. So what you are doing, you are doing it for loop over keys and values. So when you do this, you can actually write and understand like this in key and values and print what is k and v actually. So suppose, yeah, we want a space in between. So it will give you like this. So this is first one is keys, values. But what we wanted, the question was convert this key to values, values to key. So this is like shortcut for doing that. Shorthand notation, you can say. You just reverse value to be now acting as a key for this D, a new dictionary, and keys will be acting as values for that. That was the idea. So when you do d underscore dot items, so in this one you can see how they are different actually. Now a is one is actually value and a is acting as a keys.
Hmm. Okay.
Yeah, that was the question here. So for, yeah, sorting of the dictionary will actually happen on the keys. It is not going to sort for the values. We can check if you want sorting on values, you have to mention values and then it will, yeah, probably it will do or not do it based on the what is the values actually. So again, it is 6 here and others are this string,
Hmm.
it is not able to convert them. So by default, it is reversing or sorting on the keys.
Hmm.
In the list, you just saw it is going to, it's normal, right? In the list also, if you pass some names and or something, it will again throw errors. You can do for a time being. Suppose 0 1 you replace with, instead of 5 numeral, you replace with this one string element of 5, and now it will throw error if it is having
Cannot
two
compare
different,
two different data types.
yeah, data types. Yeah, int and string you cannot, but it already have strings. So definitely it will try to compare and do alphabetical order. That is the thing for strings or any set of strings. When you are doing sorting on a string itself, it is converting into one characters and doing the sorting. Dictionary is only for keys by default, but yeah, they have also reverse and these things. And sets and tuples are very much straightforward. It will are acting as a same. It can also be sorted actually. You can write sorted and pass some tuple here, saying 1 2 3 is a tuple. It will, yeah, give you a list actually. It will not give you a tuple itself. Similarly for set also. Yeah.
In
So
Python,
this,
most of the output comes in a list form, right? I mean,
yeah.
if we don't specify particularly tuple or set, it will come in list itself, right?
Yeah, this will actually, you can read about this. It is mentioned as sorted. I will return sorted list only. Yeah. Returns a new list containing all the items from the table in ascending order. And yeah, custom keys can be passed as a parameter also.
Okay.
So, okay, yeah, I think keys when they say,
We can pass three, I guess. So it will reverse.
yeah, correct, correct. Yeah. Reverse was there. Yeah. True. And we can have key also. Yeah, key is also there, I think. It's like a little advanced. So let's give you an example. Well, for this, then maybe yeah, key is also there. So suppose you have a list of tuple uh, in the say in this order. Suppose you want to do sorting of this tuple list in reverse order, and key will be first element actually, kind of. Yeah, what is int is not callable. Yeah. Hmm. Yeah, actually, now you have to mention this lambda function saying that you take one element but not compare on that element, compare on its second element or that is second element. In this way, it is sorting. So, yeah, let's make little troublesome when you put minus sign, how it should behave. And now let's see. So reverse was true, right?
Yeah.
And it is meaning so your key is x of 1, meaning x of 1 will be second element.
No, no, I'm not getting after lambda.
Yeah, so what it is doing is it is going to sort for you, but where we are mentioning key, it is saying for each of this element x, we are going to work on only this x1. When we say x1, it is meant by this actually,
Okay.
6.
Let me tell this. This x value, whatever you have given, it is taken as uh,
Each of the element
one,
one by one. Yeah, this
one.
will be one key, second time this will be next key, third will be this key. So lambdas are always like iterator kind of functions. Here we are giving one keys. So it is saying take one element of this list and come. We are doing sorting, right? It will be comparing actually. So it is comparing these two and trying to put into correct order. Then again these two correct order. And in the last no comparison is there, then inserted as it is. Let's for time being remove the reverse. We don't want to do reversing and all. So according to you, when you are going to suppose do the ascending order, so what should be ascending order for this -2, -4 and -6? So the correct order will be uh,
Mm,
ascending, right? Increasing order. Yeah. So -6 will come first, -4 will come second, and
mm.
-2 will come third. So that is the idea, but it is going to do for tuple. So it is saying I will treat these as a primary keys and do the sorting and put the all the items as it is. So that is the sorry, that is the idea here. Yeah. And for like quickly commenting things, you can control and press slash forward slash. It will comment for you. So now it is giving you the result saying -6 should be coming first, and it's tuple, -4's tuple, and -2 tuples
Okay.
in this order. That is the idea. So instead of this, if you put something like, yeah, apple, cat, or something like that, then also it should be working.
ABC 1. Okay, it's taking the value.
First, as a, yeah, this one as a main criteria to sort this tuple. Yeah, these very, yeah, helpful actually if you remember the syntax how to do this, because many times you want to actually do the sorting of list of values and values kind of things, and but based on something else. So suppose you wanted based on the, it is like student and their rank or marks, you can say, kind of. So you can do the ranking on the based on alphabetical order. You can do sorting based on their marks also, or their age also. So suppose multiple data sets were given in tuple, then how you will do that sorting? So if you pass 0, then it will be doing based on the numbers.
This is nothing but the columns, right? Like column A, column B, column C.
Correct, correct. Yeah. So these are some sorting. Yeah, sorting, I think, yeah, it will go when you go in little deeper, and you will find, yeah, many use cases of this. So one thing is Python already implemented sorting, and it is like very rich also. You can play around with key value and this reversing and all, and it can be sorted on list any types of data types actually. So no need to worry much about that. Yeah, that is the idea. Let me check anything I wanted to talk more. Case, yeah, that is. Similarly, if you go in that, what to say, the exercise I given, they will talk about nested list and nested dictionary kind of things. Generally, list will come into picture where it is like for time being, I can say, suppose your numbers was there, right? 1256. You can actually mention any of this element as again one more list, saying that instead of having 6, we can write 3 comma 4. When you pass this, it will actually converts list of list. So that this is very usual thing to play around with on the list. Functions we talked already. They have returns and all. Okay, we will, yeah, before moving. Yeah, in case we miss something, we can anytime we can come. Okay. So that day we talked about giving a path and opening some files, right? Yeah. So there are multiple modes are there. Reading, writing, and yeah,
Right.
just think when you do exercises, I think you will get some questions and all.
Yes, probably.
Yeah.
But I didn't complete, so I don't have a doubt on it now.
Okay. Yeah. So let's move one basic, how to say, library which generally used in data science is numpy, and they are actually meant for doing some things which are scientifically based on things like especially matrix operation. So they already defined for main of the things will be generally yeah, numpy arrays. They will be acting as a nothing but a faster version of the Python, little faster as of now, and they are actually, yeah, they are implemented in C and all, and yeah, linear algebra stuffs, that is like matrix sum, matrix calculation, or doing matrix arithmetic operations. Generally, like transpose of the matrix and like that stuffs. If you had some knowledge, do you remember anything? How to convert inverse of get the inverse of a matrix?
Actually, no.
Yeah. So this library is written in C, they are mentioning, and generally we use array here. They call list. List is nothing but acting as an array here, and they will have similar syntax and all, but it's generally, or yeah, we use for linear algebra stuffs. And sometimes it's very useful to convert your existing code into faster versions. And you might be remembering we talked about Anaconda. In that actually you can write this command to install the numpy. Generally it will have already installed for you, so no need to worry. Maybe, yeah, in case you are having new, and then they will have these functions and creating from the list, creating some built-in. So matrices and all you can define very quickly. And what happened, right? Any of the data type, like image data, or like song data, or audio data,
Okay.
or yeah, even the sentences and all this NLP, when we say natural language processing, those are also going to convert into some form of matrix only. Somehow we, so for image as example, you can say there we convert that image into numbers format or matrix format is uh, one is pixel by pixel. So any image like this image is there, we actually did one operation. This image, if you zoom enough, you will end up getting 1 pixel. This one, a small value, right? You can observe the square brackets. This act as
Mm.
a pixel, and this pixel will have two things. One is like which location, that is like if 240 cross 240, you can represent each of this square bracket as a one number. Like this will be the position. Yeah, 200 rows, 200 columns. You can see my cursor, right?
Yes, yes.
Yeah. So in this square bracket, and also this can be represented at RCB, that is like red, green, and blue. RGB, sorry. So these way you represent this, you can say image into one numpy array. And if you want to do something operation or tilting, whatever Photoshop and everything we do in on Photoshop software, you can do in Python actually. So we performed that one operation. We able to change the render the color, change the size of the images, and get into this format. So any
This,
of the data, like this is for this is like one use case, you can say we able to get from the NumPy. That is one of the use case, but yeah, many others are there. Yeah, you were asking. So generally, what it these things also involved was nothing but matrix operations. In the end, you represent anything into any matrix form, do some operation, return into the form which we originally it was. Yeah.
here it is like again we need to know all the basics mathematics. I feel like.
Yeah, yeah. Actually, so in the end, it is working on maths only. And for that, doing maths operations, matrix operation generally performed. Not only matrix, there will be many operations like there is this call. Yeah, there are some stuffs we call them. Yeah, I forgot.
Statistics and
Yeah, statistics is also there, but yeah, this linear algebra things actually generally. Matrix property, yeah, many properties are there. Getting eigenvalues, vector by vector comparison, getting inverse, trace, many operations I can see. Yeah.
to be frank, I don't remember the
Yeah,
concepts. It is like in
basic
columns.
one or two classes till matrix operation they talk about. You can, I think, revisit also.
Mm.
But like you should know like what is transpose is going to expected, because we I am going to write such question, meaning yeah, steps or code you should be knowing like yeah, it is the expected result. So in the first class we just going to yeah brief how we are going to import the libraries. So we say numpy as np, and you create some. Suppose you had this right nums. Okay, let's remove this to make it a better version, like this. Numpy numbers as same 5 to 10 elements. So will numbers has 10 included or not?
I did. Oh, no, -1 exclude.
Yeah, it will not include 10. So this is the one list you got from, suppose, from the meaning, yeah, you have the list of numbers or list of values, anything. Now you just write like np dot array. It will convert that list, passing that numbers into numpy array. That is the idea. Now, if you want to do some operation over this, you will actually find these are faster. Right? Suppose one operation is like nums into 2 you want to do. So, okay. No, no, okay. This is
Let me
actually
reflect like.
not not the correct way. It is actually duplicating the list of elements.
Hmm.
So this we did not want it. We wanted 5 to be replaced by 10 and 6 to be replaced by
Okay.
17 or multiples of 2. So how you are going to do that is it's this is not way to do in the list. So for x in nums, and you have to actually create another list saying x into 2 is the new list. This is the way. So yeah, I am not storing, but yeah, we can store also. So nums double, yeah, okay. Uh, okay, now it will actually multiply for you nums. But in numpy array, so let's write array, yeah, like this. You can actually write it, what to say, directly the code into 2. So this is the idea, and yeah. So this is what, right? You wanted to multiply any column or vector by 2. When it is like one dimensional, we call them as a vector, right? If it is two dimensional, they are known as matrices. So you did one operation. You just wanted to vector it, meaning convert this into list into vector and multiply each element by 2. You just write this like star 2. This is fine.
This is like the
But
same
for
operation
list, you
what we.
have to do each element wise element. Correct. Yeah, you were asking.
Yeah, yeah. Whatever we did it using a for loop, like without using a array or numpy, so that there we have used a for loop. If we are using numpy array, it is like simply a simple. It is doing a simple operation. Right? That is what we
Correct.
are differentiating, right?
Yeah, yeah. That is where we get the difference of these things. And let me go a little more. One example. In remember, we have a range actually in Python, which
Yes.
actually gives you supposing these many values for list. So let's convert this. If you write list, it will give you all the values from that 1 to million, whatever we wrote. And this. Okay. And now we are going to suppose we created one my list is this. So this is one list operation. Similarly, you can create array also in numpy, saying that np dot arrange is there. One more method similar to range, array range, and
Okay.
just pass the size. So yeah, before I make mistake over size, I just copy paste. Instead of we can remove some zeros. Let's make little smaller. Yeah. Uh, can you check? Yeah. So
And
these both are similar, meaning in the sense you want to check the element of the list in the 99 9,000 position. It will give you, I think both will give you same result. But only thing is their representation is little different. And when you print this, it will say I am array, and when you print that one, it will say I am list. And this how you can check also. One more command is checking the type of any variable. So type is there,
yes,
and
yes.
type you can check like this. And if you type array, it will say it's numpy n dimensional array. Okay. Now the same operation which we just performed, there is in Jupyter notebooks. You will have this. Sorry, this time it magical functions. So what it does, it's run your operations. So suppose you are doing list 2, which is actually going to duplicate for you. And how we are duplicating the same command for list. And suppose you want to do the same thing. Let's do for this. First, you are duplicating that, sorry, this one. Thousands of element, 10,000s of elements. Oh, sorry, not 10,000. I think 100,000. That is 1 lakh. And checking how long it is taking. So you can see. Actually, yeah, this VS Code already have this, what to say, timer. So you can see it took like 9.6 millisecond to do this operation. And for this time being, when you use time it actually runs 7 times.
Is it like
And
some fixed kind, 7 runs?
yeah, kind of fix, and it's decided by compiler itself, or this time based on the size actually, how long or how small it is. And it is saying that for doing this operation, it is going to take 9.6 millisecond. And let's do create the duplicates of this time it for array actually. So suppose we do this operation. Let's see how long it takes. Yeah, almost. Yeah, so you can check that it's in milliseconds, but these are in microseconds, so less actually. And for time it function, what it does, it instead of only checking for 100 loops, it tries for 10,000 loops to get this value. So for actually, yeah, for time being, you can remove this and check. It took actually zero point 0.4 second. But what is right idea was for doing these operations, this numpy arrays will be very much computationally faster actually. That is the thing I wanted to convey here. Any questions?
No question for now.
Okay. And you can meaning observe the results will be similar, but only thing is their types, data types are different. That's all.
And displaying and type is different.
Yeah, display is actually, I think it is going to print everything because of this editor limit. It is not printing for us. Yeah, let's mention some high number. I don't know, will it work or not. Next time onward, it should work. Yeah. Yeah, yeah, it is limited by the. Otherwise, in this one notebook, it will work. Yeah. And for this same, you can also check it is twice of each of the element. Okay, this is one thing. NumPy array we defined. Then we move. So for NumPy arrays, we can define actually two-dimensional arrays. That is actually mainly used for any of the operations. You will also always be having what to say, always be having two values, two rows and two columns, something like that, or three rows, whatever, and say it can be anything, any number, point 0.5 and 6. And yeah, generally just observe the syntaxes. Its syntaxes are little tricky sometimes. So data will have like it will represent into matrix format. That is the idea.
One
You can
second.
easily say, yeah, and
Uh, for the first one, on the output, it is giving 1 point something, but whatever we defined is like just an integer, right?
no, no, first one is all integer, but second you can define anything. And the third one is also,
No,
uh,
uh, how to tell it?
no, no,
In the
third
first,
one is also integer, but in representation it will actually treating them as I think float as of now because one of the element is a float. It will convert all the elements into float. I think, yeah, and if you're, yeah, try with this, and then actually, or otherwise it will, yeah, wow, wow, wow. Oh, yeah, correct, zero. Yeah, then you can see it is all integer.
okay, based on the elements, it is converting it. If one is float, it is converting both the arrays float. If one is
Correct.
integer, both is integer. Okay.
All are actually. It is
Okay.
treating entire thing as one array. So it will try to change accordingly. So yeah, this is nice observation I also found. Like it will convert based on any one element. And now suppose you wanted to do some operation over it. You want to do 10 times of each of the element. You can directly do like this. You can, I think, divide also similar way. So these are like very faster way to do this. That's why we need these operations. And suppose you want to do take the sign of it. Remember we imported sign. I think it will be there. No. 1D array scalar can be converted. Okay. Think I will have. Yeah. So in this way you can use numpy sign. So this you understand, right? It is doing the sign operation for each of the element.
Initially, when we gave just a sign, it threw an error. When
Yeah,
we
because
gave
sign was not defined, or yeah, sign was meant for scalar operations. Yeah, a list. But this sign is like numpy sign. They will actually implement it in larger, broader sense. So it can be applied to all of the element. Similarly, we will have exponential also. You can take exponential of each of the element, and many more will be there here. So whatever the scientific calculations we need, generally you can directly do this. Suppose you want to add one element or some five to each of the element or four to each of the element, you can directly do this. And you want to add two of the matrices, this is easily doable. So let me, for timing, I should, yeah, copy these and keep it here only so that later on, in case you want to revisit, you can do it. Some, yeah, numpy dot sign. So this is some we did. Yeah, multiply, divide also. Remember, yeah, so data divided by 0 will throw error because 0 division is not possible. It will throw not error. I think it is just giving you warnings. Divide is so it is just representing one INF, that is numpy's way to define infinity. Yes. Okay. So yeah, and sometimes we want to take inverse of anything. You can write like this also. Uh, Maybe they are not saying. Again, I think we may be needing inverse operation. Inverse. Let's see this, what it takes. Yeah, data. This is also not possible. Yeah, we'll check. Inverse is there, I remember. NP dot. So, okay, yeah, we can directly do this. Oh, sorry, I forgot. So, one by something in of each element actually. So, data was two, right? So, one by two is what? One. Hey, sorry, one by two is not one. One by one is one. This element. So, data was actually we should print here data. Then you may observe. Yeah, this. So 1 by 3 is represented like this. 1 by 4, 0.25, 1 by 6, 0.166 and all. Okay. Yeah. So this
One
is
doubt.
nothing, I think. Yeah, these are like doing all the operations on matrix, but writing for code actually. We used to do these actually like doing maths and all for these algebra classes and all. I think, yeah, we have many things and we cannot cover today, I guess so.
One doubt I have.
Yeah,
So
ask.
it is like in what is this fund numpy?
Yeah,
In
numpy.
numpy, that package itself is having different mathematical calculations, like whatever you said, that sine, cos, and inverse.
Yeah, yeah.
Separately
So
also we can import like with import math as sine like that.
math is
So
one library which is general to Python. NumPy is one library which is general to arrays.
numpy should to array.
Yeah, it's like you can, I will pass this or yeah, you can read this. NumPy has many built-in and capability. We will focus some important aspect, vector array matrices, number generation, and these are predominantly used in the linear algebra for Python. So that's why we need some libraries to understand some of the algorithms, right? Machine learning algorithm and other things are generally used NumPy actually. So in the backend, they write. So how these packages work is right is like someone wrote some code, they will store and meaning open to everyone. On top of it, other people come and write something. So it is like NumPy got famous. It is already written many functionalities, very well diverse, and they are now actually used by other library makers or creators. So if you find something good or interesting use case, you can also do this and call this as a one package of yourself. So many Python packages you will find in later.
Okay.
Yeah. So yeah. Any more question?
Packages and libraries both are totally different.
Similar, yes.
No,
Nothing.
no, they are different as say.
No, no, same, same. Yeah, library or package. I am just, yeah, interchangeable word.
Okay,
Yeah, if you go in too deeper, definitely you will say package is like, yeah, any container or anything. Any box is coming in with the wrap, that is also one package.
okay,
So it is both actually.
okay.
Same actually. Yeah.
What
So
else?
n
Any
dimension, this one keyword is there. It is telling you like it is two-dimensional array. So remember, you have this one my array. If you write ndim, you will say you will find one dimensional and all.
no.
Correct. And you will also have a dot shape is there. Will give you, so how many? Two rows, three columns,
Okay.
right?
Okay. These are the keywords that should be aware of, I guess. I
Yeah,
need
yeah, basic
it.
keywords. Yeah, you should aware. So suppose someone asks, gave a data frame very big, you read it as a numpy. Now, if you want to, he asks like how many rows it has. So for a small case, it is giving two and three, but when it's bigger, you have to know like how to get it. So for rows, you will say zero. For columns, you will say like this. But yeah, it can be three-dimensional also. Then you will see other values also. These are the things. Similar way, you will have this one NP zeros. It will generate any size of array for you in zeros. Like this is like initialization. You want any matrix to be created. You know, like yeah, 10 values I need, or 10 cross 10 you need. Sorry, we need to pass probably like this. 10 cross 10 initialize with zeros. You can write like this.
This is like
Similarly,
a dummy data, like we'll have a
yeah,
dummy
yeah,
data.
initializes with zero, not dummy. And similarly, we also have np.empty actually. I think this is for when you know like initial value should be zero, then also you can, yeah, zero only. Both are actually giving zero. So, so 10, oh, okay, yeah, actually not list, you can pass tuple also. 2 comma 3 or 4. 3 is better, yeah. Oh, why it is giving, actually it is representing zero, but in a different format or,
This is some float value.
yeah, some, yeah,
Maybe
higher
in the option.
precision values. Let me try this. Ah, just now empty was giving, oh no, we wrote zero only. Yeah, correct. So any garbage value it is giving actually. So this is very insignificant garbage value. It is, we should not care much about this. We talked about one more thing was np dot arrange, that is giving you arranged value till starting point is that, ending point is that. You can actually give start also. So suppose you give 13, yeah, then two values will come again, the same thing. You will not get the last value. One second. Yeah, so these are the things. Many more will come into picture. Similarly, you can write, I think numpy dot once is also there. Once, all ones.
These are the function or method that it's having in the numpy icon, like how we
It
added
is, yeah,
it.
giving you a, uh, yeah, it is giving you list, right? Array, sorry. Yeah, can you repeat what you are asking? Hello?
Yes, Rishi. Yeah, I said yes.
Yeah, okay. So all these things, I think, while defining any array, uh, you can tell actually. So just for example, let's say when I say tell, meaning you can define how you want to define them. Saying one, two, three is there. Then you can mention one more value, d type. You is like d type is nothing but data type. What type of data? If you write int explicitly, it will take as a int, and when you mention float, it will tell you float. And yeah, even in this also they have this integer 32-bit, yeah, and float 128. How precision we need? I think these will throw error because your computer or numpy don't have. So we just say float 64 actually. Generally we go 64-bit floats, and numpy will have integers will 32-bit array 1. Yeah. So suppose let's see. I just see one upon this. Oh, so suppose is here writing for you.
No, I'm not understanding the.
Uh, Not in detail. Sometimes you have to define the data type of each of the element, what type of data type you need. And by default, I think it is 64-bit. That's why it is not mentioning you. It is 64-bit. But when you write like this type of array 1 of third
Array.
element, supposing, so it is saying, going to say you like it is numpy but 64-bit float value. But if you mention them 32-bit, it will be mention you for 32 bits. So
Okay,
I
here
think
whatever
you
value
just,
you mentioned
yeah,
is the
know
array
this,
just
they
times
exist,
4.
two different data types. Yeah, you were asking. Hello.
Hello,
You,
am I audible?
yeah, yeah.
Okay, yeah. I was telling like whatever value we have defined inside that array, one, two, three, everything it is treated as like the float or whatever the number you're specifying, float 32 or float 64,
Hmm.
right?
Yeah, those numbers are now treated as this type of data type. That is the idea. And why I am telling, sometimes because of these data types, uh, meaning data type different, you will be not able to see expected results. So make sure they matches. Suppose you want to do two array sum. So because these numbers can be in decimal places, right? What will happen? It when it may cause errors. Suppose you have not this number, so 567, and now when you take the inverse, then actually you can notice the difference. That is what I wanted to show. See, it's after this many decimal point, it got changed. 7 is there with 32-bit. But if you notice with 64-bit, I think you will find it is more precise values. For threes, especially you can see this one, but I don't not able to see for the other ones. Yeah. So that precision and all errors can occur. That is why I am saying you should keep them as a same data type formats whenever you are doing some operations. That is the only idea and like main intuition here. And you can convert them also using sorry, array as type is one conversion function is there. You can directly convert either integer, whatever format you want them to convert. So float or saying numpy float some. But I think float is not, you have to mention 64 bit by default. Yes. This is one of the way to as type. Remember this keyword as type will convert any type of array values to whatever format you want or data type. And I think you can also mention a string. You can see it's converted for you in a string also. Oh, and vice versa also. If you got strings of numbers, you can convert back to integer. I think some error is coming, but yeah. Oh, okay, because it was, yeah, not numbers, right? That's why. So let's say if it is int, then definitely it will come 32 bit, I should mention. Then it will work. Yeah. Why it was not working? Remember, just you observed, right?
You have given float
Yeah, because float 1.0 you cannot convert them into one
into
actually.
one
1.0 they, it's a string, right? And it's not able to convert into integer. That is why it was error. So, but if it is integer, then you can definitely convert back, reverse back. I think, yeah, later we will talk about slicing. It is similar to that slicing and all, and some comparison and other reshape and other functions. We will discuss tomorrow, I think. Yeah, enough for today, I guess so. Oh, uh, yeah, that's all for today. Are you good or like you want more?
precisions. These are like most used kind, or still we have some more like
Many
un
more will come. Actually, these are some basics. Yeah. Let's visit. We talked about creating the arrays. There was arrange method, zero methods. We talked about, yeah, this linspace we will talk tomorrow. I is identity matrix. Random is also there. We will talk tomorrow about these. And random reshape we will talk. Min, max, and shape is there. Shape we talked. Reshape we can talk now itself. Data types we just talked. So yeah, reshape we can talk quickly maybe. My array is there. Sorry, array value is there, right? It is having how many values? Six values. So you can actually reshape them into some different formats, saying three rows, two columns will convert for you the same array into different data format.
it's like dimension changes we are doing here.
Dimension changes, correct. Nice. Yeah. Yes, if you write 2 cross 3, it will convert the same into different dimension.
Okay.
Sometimes we need to do this, and these are the some things. Dimension changes. We it has I also. We forgot to type. Sorry, np dot. Let it this. Let it. Sorry, yeah. Let it be there, and we wanted, right. I is nothing. One more default actually. Identity matrix, if you are aware of, they will be always into 3 cross 3 value, or
Two hosts.
it was always row and column will come, but notice the diagonals will be one value. This is for identity matrix, we call them general actually. Yeah,
Keyword is I. Okay.
identity matrix. Yeah, you can, yeah, in case you can check. They have like significant use case, that's why, like, yeah, let's predefine them. No need to write code for that. Yeah, otherwise you can also generate some code and, yeah, write them. Correct. I think net is not working so good. Yeah, identity matrix. In algebra we have. Think yeah, that's all I have for today. I will yeah, remaining we'll talk tomorrow, I think.
Okay.
Okay. Okay. Let's stop sharing.